Hello, today we're looking at alpha substitution of carbonyl compounds, and this is brought to you by Science Visualized. So if you look at a carbonyl compound, that's a carbonyl group, and then the carbons next to it will be alpha carbon, then the carbons next to that will be beta. Now let's focus on the alpha carbon. If you look at this alpha carbon, it has a CH3 and a CH3 group, therefore it doesn't have any hydrogen. On the other hand, this alpha carbon actually has two hydrogens. So if you react that with LDA, LDA is a bulky base. It's in full lithium diisopropyl amide. It's a very good base for deprotonation of the alpha position. And the LDA looks like this: lithium plus, and then amide, diisopropyl amide. So the nitrogen is a good base, therefore it will abstract a proton, it will pull out one of these protons, and then the bonding electrons between carbon and hydrogen will flow to form a double bond, and then at the same time you break the carbon-oxygen double bond, and two electrons will flow to the oxygen to make O-, and then this hydrogen leaves and the electrons flow to make this double bond. So this intermediate that has a minus charge on oxygen, and that oxygen is connected to this carbon, which is a double bond, is called an enolate. If the intermediate has OH, then that's called an enol, and they both react the same way. Next, the enolate will react with electrophiles. So if you have an electrophile here, remember electrophiles are Lewis acids that will accept electron pair, the enolate becomes a nucleophile, and therefore we're going to have the two electrons on the oxygen, the O-, flowing back to form a double bond, and then at the same time, these electrons through that carbon connects to the electrophile, and you end up with the electrophile connected to that carbon. So in this case, we are using an alkyl halide, RX, so that's the alkyl group, and that's the halogen, iodine. So alkyl iodide as the electrophile. So the same thing is going to happen. First, the minus charge on oxygen, that means two electrons will flow to form a double bond. Remember, we're using double-headed arrow because it's two-electron process. And then the alpha position carbon, so this double bond through that alpha position will connect to that carbon with the iodine, and then the iodine leaves. So that's basically an SN2 substitution, where you have the whole of this enolate group substituting iodine. And therefore you end up with what used to be the enolate part connected to the alkyl group, that one there. And you can see that the new bond here is in red. So you end up adding the new group to the alpha position. So that's an alpha substitution reaction. Thank you very much for your time. If you enjoyed this presentation, please consider supporting the channel by subscribing.